We're going to write an equation for the tangent line to the potato. Not really a tangent line to the potato, but we'll pretend it is. Okay, so what's our tangent line? Well, first off, we need a slope and we need a point. The point should be 0, 91. And the slope should be whatever you get if you plug in 91 to this. Which is what? Looks like negative 16, if I subtracted right. Is that right? Oh, look. So we end up with y equals negative 16t plus 91. Might as well put it in slope intercept since they gave you the y. Everybody good there? All good? Okay. And then approximate the internal temperature at T equals 3. What does that come out to be? 43. That seems good to me, right? 91 minus 48 is 43. 43 degrees Celsius. Everyone is good with that? Part A easy. I was gonna have the scoring guidelines up so I could tell you how many points it was worth. But then I started looking at cars online because of Ben. I blame Ben. Where'd it go? It's not this one, it's the other one. That was probably worth 2 points. I remember when this problem was on the AP test in the class, they whined and said, I didn't know how to do the potato problem. That was the AB kid, not the BC kid. The AB kid, I couldn't do the potato problem. Yeah, it was on, yeah, there's overlap sometimes. So this one was on both tests that year in 2017. And the AB kids all whined that they couldn't do it. And I was like, it was just like the baby bird problem and the trash problem. And they were like, what? And I said, remember the baby bird and the trash problems we did? And then I went and had to show them in their notes about the baby bird and the trash problems. Anyway, that was worth, wow, that was worth 3 points. Unbelievable. 3 points. 1 for the slope, 1 for the equation, and 1 for 43 degrees. That's great. All right. Part B, find the second derivative and use it to determine if it's an under or an overestimate. So second derivative, we'll just take the derivative of this with respect to t, which should be negative 1/4 of dh dt, or a positive 1/16 of h minus 27 if we plug in dh dt back into that. So how does that help us determine if it's an underestimate or an overestimate? What do we know about this second derivative? This second derivative is always going to be, it's always going to be positive because the temperature of the potato is always greater than 27 degrees Celsius, is always greater than 0. Tells us that the function is concave up. Right, and the tangent line will always be an overestimate if the function is concave up on the end. I just drew that concave down, didn't I? Why did I draw something that was concave down? I'm not thinking. There we go, underestimate. I don't know. Why did I draw that concave down? I have no idea. All right, underestimate. Everybody good with that? That was worth 1 point. Seems like that should have been worth 2, and the other one worth 2 maybe, but whatever. All right, that's part C is they gave you an alternate model and solve that differential equation and then find the internal temperature of the potato at T equals 3. Good? So we got dg dt was that thing. I'm going to separate the variables to begin with. So just I'll have a negative 1 dt over here. And on the left-hand side, I'm going to have a g minus 27 to the 2/3. Everybody good with that? Separating the variables. Integrate both sides. Negative t plus a constant. And then this side, this is g minus 27 to the negative 2/3. So that'll go up to positive 1/3 and become a 3 times g minus 27 to the 1/3. Everybody good with that so far? If you got that far, that was worth 2 points. 1 for separating the variables, 1 for the correct antiderivatives. Then plugging in your initial condition, which was 91, right? I think when t equals 0, the temperature was 91. -27 is 64. Cube root of 64 is 4 times your 3 is 12. So you get a constant of 12. Everybody good with that? Put in your constant. If you used your initial condition to solve for your constant, that was worth another point. Then solving it for g was worth a 4th point for this one. So that would become g equals, let's see, what do we end up with there? We end up with 12 minus t. That does not look like 12. 12 minus t over 3 cubed plus 27. Everybody good with that? That's worth 1 more point. And then g of 3 would then be whatever that comes out to be. What is that? 12 minus 3 is 9, over 3 is 3, 27 plus 27, 54 degrees Celsius. That's 1 hot potato. Just one. 1 hot potato there. Only 1. Everyone good with that one? That was worth a 5th point for that one. That was a pretty easy one. I hope. Didn't really even require any DC stuff. Easy. Y'all are good. People at home, are you good?
Good.
Great.
Great.
Wonderful. How many of you actually did this second one here? Yeah, I know that none of you did. I know that Ben did. 1/4 of the in-person people. Yes. Yes, Kevin, I know you didn't do it. How many of you did the problem? Did any of you actually do the problem?
I did the problem, and presumably some people did the problem and other people didn't do the problem. So we could go over it because there's like 20 pages of differential equation stuff for people to practice, even if they didn't do it. So yes.
All right. The truth has convinced me. We're going to go through it. You don't get any time to work on this one, Noah. All right. Find the second derivative. Easy enough. That should be straightforward, right? Second derivative should become 2x minus 1/2 of dy dx. And they say in terms of x and y. So we need to replace the dy dx with the value for dy dx. So this becomes 2x minus 1/2 of x squared minus 1/2. Easy enough for part A. Distribute the minus sign through if you feel like it. If you don't, then don't. Good? I don't have the guidelines up. I'll pull up the guidelines and tell you how many points everything's worth on this one in a second. Part B, what do we got? Y equals f of x is the particular solution. Goes to the point -2,8. We want to know, does f have a relative min, max, or neither at -2,8? So first thing we need to check on whether it has a min, max, or neither is whether the derivative is 0. Right, or undefined, but it's not going to be undefined. So first we'll plug in -2,8 into this. So -2 squared minus 1/2 of 8. That ought to be 0. Everyone agree with that? So potentially, yes, it could have a max or a min. If that came out to be anything other than 0, then we would know that it was neither for sure. Then we'll plug in -2,8 into our first derivative. Sorry, our second derivative. We already did our first derivative. Our second derivative. So that's going to give us 2 times -2 minus 1/2 of -2 squared, and then plus 1/4 of y, which was 8. And what does that come out to be? -4 minus 2 plus 2, which is -4. And since that is less than 0, that tells us that this thing is concave down. This time I'll draw it correctly, which tells us that it is a maximum. And you'd say it's a maximum because the first derivative is 0, the second derivative is negative, meaning the function is concave down, therefore it's easy enough. Going good there. All right, part C. We got g of x, which is the particular solution to the differential equation with g of -1 equal to 2. Find the limit as x approaches -1 of that thing. So first off, plug in -1, gives you gives you 0 over 0, right? So we will use L'Hopital's rule. You will write that you used L'Hopital's rule. What we're approaching 2, -2, -1. So -1. The derivative of the numerator is g prime. The derivative of your denominator is 6 times x plus 1. Right. 6 times x plus 1. Yeah. Okay. And then if we plug in -1 here, we got g prime of -1 over 0. Well, what's g prime of -1? That's this when x is -1. We know that that would be 2. We end up with 2 over 0. So we would say that that limit doesn't exist. That doesn't seem right. Oh, that's g of -1, not g prime of -1. Sorry. So that doesn't seem right. What's g prime of -1? Does it come out to be 0 also? They didn't give us that though, did they? Yeah, plug it in here. Yeah, plug it in and find it. -1 squared minus 1/2 of 2 is 0. So we get 0 over 0. So we use L'Hopital's rule again. Get the limit as x approaches -1 of g double prime of x over 6 this time. And now g double prime, we'll have to go back and plug in the point -1, 2. What did that come out to be? -2. So we end up with -1. Good? Everyone good with that one? Make sure you write out that you're using L'Hopital's rule. Actually write it out. Don't just write LH. And part D, we're going to use Euler's method. 2 steps of equal size, starting at x equals 0 to approximate h of 1, given that h of 0 is 2. So we've got the point 0, 2. What's the value of dy dx there? At 0, 2 should be, plug in 0 and 2, you should get -1. And we're going to multiply that by our step, which is 1/2. Right? So that's going to give us -0.5. So this will go up to 1, and this will go down to 1.5. And then we'll plug those in to our dy dx, which was still a 1 there. So 1 minus what was it, half of that? So half of 3/2, so 3/4. Oh, yeah. You're right. So what did that give us? -1/8. Did I do my arithmetic right? Nah, that should be a 4th. That's a half squared, huh? 4th minus 3/4. That should be -1/4. I should do arithmetic right. Is that better now? half, 1.5. Everyone agree with those? Half and 1.5? Yeah? That's 1/4, that's minus 3/4. Should be negative 1/2. No, there should be a negative 1/2 times a positive 1/2, which gives us negative 1/4. Everyone's good with that? Okay. So we end up with 1 and then 1.2. Good? I gotta do arithmetic right. Any questions on that? Do we want to know what the point values were or no? What? Does anybody want to know? I can look up the scoring guidelines if anybody wants to know. All right. Guess we won't. Let's take a look at this one. This one. Do I want to? This one I think I want people to do. So if you do not do the problems, I want you to take, I don't know, I'm going to give you like 8 to 10 minutes to do this one. Those of you that did do the problems, feel free to just go down to another one. I guess you can't go down to another one, can you, Ben? You don't have them printed out? It's like you have just the ones that we did. Ooh, that's a good idea. That'd be fun. Could call people on the walkie-talkie. I'm not sure if it's working or not. Oh, the green light flashed. It must be. Nobody said anything. It's no fun. I feel like normally there's people all over the walkie-talkies, but now it is. You have to show your work. You can just sketch it. No. All right, you guys are working at home, right? You're actually doing this problem?
Yes.
Okay.
Yes.
And still dangerous. How'd you guys do with this on Zoom? Did you guys do this now that you've had the chance to do it?
Yes.
Great. Okay. What did your slope field look like? Probably just needed to plug each point in. It's probably easy enough since there's only 6 of them. So 0, 1 should have given you -1. And 0, 2 should have given you -2. And 0, -1 should have given you +1. And then 1, 1 should have given you +1. And 1, 2 should have given you 0. And 1, -1 should have given you 3. Good? And let's see, yeah. They gave you 1 point for these ones and 1 point for these ones. Oh, clearly, yeah. So hopefully you didn't mess up 1 in each column, because then you got 0 points. That would suck. Usually it's like 1 point for all the ones where the slope is 0 and 1 point for all the rest. But for some reason, this one was in columns. Maybe because there was only 1 point where the slope was 0. I don't know. All right, everybody good with that? 2 points there. Everyone's good there. Okay, part B, find the second derivative. So that should have been 2 minus dy dx, or 2 minus 2x minus y. And then determine the concavity of all solutions in the second quadrant. Well, in the second quadrant, what can you tell me about the second quadrant? X is negative, y is positive in the second quadrant. If x is negative and y is positive, this will always be greater than 0 in the second quadrant. And so therefore the concavity is up, concave up. Everybody good with that? Okay. Part C, also easy, I hope. We got y equals f of x as a particular solution with the initial condition that f of 2 is 3. We want to know, does f have a minimum, maximum, or neither at x equals 2? Well, plug in x equals 2 and y equals 3. And what do you get? 1. So neither. Why? Because the derivative doesn't equal 0. There's no critical value there. And so A, B, and C should have been really quick, easy, and straightforward, I hope. D is where people started having some difficulty, probably. Okay. So we want y equals mx plus b. This is going, y equals mx plus b is the solution to, what was it, dy dx equals 2x minus y. Okay. All right. So first thing we need to think about is, if this is the solution to this differential equation, this is just a linear thing, right? True? What does that tell us about the slope of the tangent line to this thing? Well, what is the slope of the tangent line, or the slope of the function? It's just m, isn't it? Okay. So that tells us that m is dy dx, or m is 2x minus y. Everybody good with that? Yeah? Okay. So if m is 2x minus y, well, what else can we do? So we also know that y is equal to mx plus b. I don't know why I wrote that again. But if y is mx plus b, we'll just take that and we can replace the y with mx plus b. So we've now got m equals 2x minus mx plus b. Everybody good with that? Okay. Now this is where we have to get a bit creative. We'll note that we really only have one variable here. The one variable is x, right? Everything else is just constant. M and b are just constants, even though they're unknown constants. The value of that constant is unknown, but they're just constants. So what we're going to do is we're going to gather everything onto one side. So we're going to say 2x minus mx minus b minus m is equal to 0. And then we're going to use the whole idea of solving the equations that we come up with partial fraction decomposition. The idea of just, well, we have how many x's on this side and how many x's on this side, set those equal to each other. We have constants on this side and constants on this side, set them equal to each other. So how many x's are on the left? 2 minus m x's, right? 2 x's and minus m x's. 2 minus m x's if we factor the x out. And how many x's are on the right-hand side? None. And on the left-hand side, we have a constant of negative b minus m, and that should be equal to a constant of 0 on the right. So we end up with m equals 2 and b equals, if m is 2, that should be b is negative 2. So it should be that simple. It's not as bad as it sounds, or as bad as you made it out to be, probably, but yeah. Hopefully you saw that that was the way to do that. That part was, I didn't tell you any of the other parts, did I? I did. I told you the first one. That was, first part was 2 points. Second part was 2 points. Third part was 2 points for neither. And then this part was 3 points. One for noting that the derivative of y equals mx plus b is m. 1 for setting 2x minus y. So 1 for just this, 1 for this, and then 1 for this. And yeah, right there now, good question? Yeah. Oh, okay. It might seem a little weird, and we're saying y equals 2x minus 2 satisfies the differential equation dy dx equals, what was it, 2x minus y, right? And it seems a little bit weird, but not really. I mean, what's the derivative of this? What's dy dx? It's 2. Well, that still seems a little weird, right? But not really, because what's 2x minus y? This is 2x minus the 2x minus 2. It's the same thing. Good or no? All right. This is the last one I asked you guys to do after that, yeah? Or did I this is the next one? This is the last one. Okay. All right. We'll just go through this one. First, we'll find the limit as x approaches 0 of this. If you try to plug in 0, what do you get? So we'll use L'Hopital's rule and get the limit as x approaches 0 of f prime of x over cosine x, which gives us a cosine of 0 or 1 down there. And then f prime of 0. How do we find f prime of 0? Just go and plug in 0 and -1 into our derivative, which gives us 1 times 2. So it looks like that should come out to be 2. Everybody good with part A? Yeah. Part B, using Euler's method, starting at x equals 0, 2 steps of equal size. So we're going to start with myself more room there, but I didn't. 0, -1. 0, -1. If we plug that in here, is going to give us, like we already found, 2 times our step of a half should give us 1. So we should go from 0, -1 up to, we're approximating f of 1/2. I should have read the problem. Never mind. Approximating f of 1/2. Our step is 1/4 arm, which gives us 1/2. Wish I'd read that. We end up with the first point is 1/2, and then if we're going up a half from -1, that should give us -1/2. Still. There we go. I don't know why. I'm so used to doing it with, yeah. Anyway, 1/4 -1. You good with that now? Be careful with your step size. Don't do something stupid, like put the wrong step size. All right. Y squared is going to be -1/2 squared, so that's a fourth. And then we've got 4 times, we end up with 2/4 or a half plus 2, so that should be 5/2. And we got to multiply that by our step, which is a 4. I'm going to do that correctly this time. What does that give us? 5/32. Oh, fun. Okay. And so we end up with the point 1/2. And I don't know, what is that? Negative 11/32. Good? Everybody go with part B? And then part C, solve the differential equation. So separate the variables. Integral of y to the -2 ought to be -1 over y. This becomes x squared plus 2x plus c. Our initial condition was 0, -1. Is that right? I believe. Yeah. So we get a 1 equals constant. We have -1 over y equals 2x plus 2 plus 1. And we're just going to take a reciprocal of that and make it negative. So we end up with y equals -1 over 2x. Why did I, oh God, I'm writing horrible things in here. X squared plus 2x plus 1. No, yeah. X squared plus 2x plus 1. Better now? Feel better about that then? Because I wrote the function instead of the derivative. Pretty easy if you don't go really fast and make stupid mistakes. Everyone's good with that one? Yeah. Yeah. Everyone's good. People at home, are you good with that one?
Good.
Okay. How do we feel overall about the differential equation FRQs? Good? Good? Yeah? Good. Wonderful. Let's see here. This is the baby bird problem that I told them. I said when they couldn't do the potato problem, I was like, we did the baby bird problem. It's the same problem, essentially. Should we do the baby bird problem, or should we do one that's got, oh, there's the trash. There's the baby bird and the trash. Remember the trash problem? I kind of don't want to do either. I mean, I don't know. You guys want to do those or no? They're pretty easy. I don't want to do that. Let's do this one. Because this one's got a Taylor polynomial in it, and it's got Euler's method in it, and it's got you solving the differential equation. I think that's a good one. I'll give you guys 15 minutes to do this one. It probably won't take that long. Oh, I'll give you like 12 minutes, so we have time to go through. No, it is not. I don't know. Let's see. The first four, that's 5, 6, 7, 8. It's 8. Number 8. All right, ready to go. We'll just pick it up there on part C with the recording. Oops. So we separate the variable. We factored. We separated the variables. We integrated plus our constant. And then what do we get? What was the initial condition again? It was f of -1 equals 2. So negative natural log of 4 equals -1/3 plus c. So your constant is 1/3 minus ln 4. Everybody good there? Yeah. And so then we have negative ln absolute value 6 minus y equals x cubed over 3 plus 1/3 minus ln 4. Get rid of your negative. Can we get rid of the negative and the natural log in one step? Will people be okay with that? I hope. So the negative and then the natural log is going to give us e to the positive ln 4 minus x cubed over 3 minus 1. Yeah. And then first off, we'll clear up the absolute value and get a plus or a minus. The plus or the minus. Which one do we choose? Which one? I don't know. 6 minus y. When we plug in our value of, what was the value? We plug in 2, we need to get, no, we plug in -1, you need to get 2, right? Is that what it was? Plug in -1, you need to get 2. So this is a 4 e to the negative x cubed over 3 minus 1/3. So if you plug in -1 to that, that becomes e to the 0. So we need this to be the positive version of this, because if you plug in -1, gives you a positive 4 over here. And you plug in 2, you get a positive 4 on the left. So you want to keep it as positive. And we end up with y equals 6 minus 4 e to the negative x cubed over 3 minus 1. And all of that was worth 6 points. Let's see here. 1 for separating the variables. No, that's not separating the variables. 1 for separating the variables. 2 for the antiderivatives. 1 for the constant. 1 for finding the constant. 1 for solving. And since I forgot to record, we'll just go back. We just did Euler's method. Plugged in the point -1, 2 into the derivative to get 2. Well, to get 4, and then a half was our step to get 2. And so we went to -1/2, 4, and did the same thing and got that. And then this was f of -1, f prime of -1, and it's x plus 1 because we're centered at x equals -1. Then f double prime of -1 times x plus 1 squared over 2 factorial. That was the polynomial. Everyone good there? Everyone's good with that whole problem? All right, cool. We'll stop.